Hello everybody, we are going to be on page 34 today talking about the volume of a pyramid. Today we are going to cover this, and tomorrow we'll talk about, or well, whenever you watch the next video, you're going to talk about volume of cones, and those are the two volume things we're going to really focus on this week. So my first one, volume of a pyramid. So the volume of a pyramid is a little bit different than a volume of prism and a cylinder, right? With a pyramid, or sorry, with a prism and a cylinder, you had two shapes on top and bottom, and essentially you have a bunch of those shapes stacked in between, right? If you have a cylinder, it's a circle with a bunch of circles stacked on top of it to get to the top. Pyramid's a little bit different, right? It starts as a big one and then it gets smaller all the way up to the top till it gets to a single point, right? It just keeps getting smaller and smaller and smaller. So we have to account for that, and really the formula is really easy to account for. All it is that you take a third of it. It cuts it into a third, and you can watch some pretty cool videos if you Google it that show you why that happens. But essentially, when you keep taking pieces off all the way up, it takes off 2/3. It cuts it down to just 33% of what it was. So with that, we have our formula: 1/3 base times height equals the area, or sorry, the volume of a pyramid. You can do that in two ways. You could do that by multiplying by 1/3 if you want to as a fraction, or you could just treat it as divide by 3. I usually use divide by 3 because it's a little bit easier to type in your calculator, right? You just do the area of the base times the height, divide by 3 at the end. So that's usually what you'll see me do. With that, let's jump to our first example. So my first example says, find the volume of a rectangular pyramid with 4 feet and 5 feet dimensions on the base, it says bases, but I meant base, and a slant height of 7 feet. So before I do that, let me just get a rectangular pyramid to put in here. Rectangular. Instead of me drawing one and just confusing you because you're going to be like, what did Mr. Knock draw? That looks like hot garbage, because it will. It'll look like hot garbage. Pyramids are very hard to draw. Okay, so here is my little pyramid that I'm going to look at, right? And so it says that the base has dimensions of 5 feet by 4 feet. So I know that this side is 5 feet, this side is 4 feet, and it says it has a slant height of 7 feet. Remember, the slant height is if you started at the peak and came down the side at an angle. So this is going to be 7 feet long. And with that, actually, hold on. I'm gonna I think there would be different slant heights. I should have clarified that. I'm going to do it the way I did at my notes. You would probably want clarification on this in an actual problem. They would have to tell you. The way I did it in the notes is I came down and made my slant height go this way. That's how I did it in the example. So let's just stick with that. Okay, so area of the base is my first step, right? Find the area of the base. Well, to find the area of the base, we're just going to pick our formula. Well, in this case, my base is a rectangle, so my formula is going to be base times height. My base times height is going to be 4 and 5, so I have 5 times 4, so area equals 20. Boom, have that done. The next thing I need to know is the height of the pyramid, and you got to be careful here. If they gave you the slant height, which is really useful for finding the surface area, it's not helpful for finding the volume, because height should go straight down into the middle of my shape, and this one doesn't. So you got to think about, if you looked at this shape head on and you saw the slant coming down sideways at 7 feet, we want this height going straight down. Well, think about this. If you're looking at it straight on from right here, right, because this is where you can see, if you look at it this way, you can see on the left hand side that slanted hypotenuse at 7. Well, this is being split in half, though, because this height is at the dead center, right? So this would be the rectangle. Like, if you looked at it, this is technically what we would see, right? That would be the front of the pyramid if you looked at it. And I know this entire length across the bottom is 4 feet. Well, that tells me then that this has to be 2 and this has to be 2. So I have this right triangle with sides 7 and 2. So I'm going to use a squared plus b squared equals c squared. I'm going to use my Pythagorean theorem. Ultimately, I know that my hypotenuse is 7, so that has to go in for c. And my other parts don't matter. So I end up with 4 plus b squared equals 49. Subtract 4 from both sides, I got b squared equals 45. And I get that b is equal to the square root of 45. I'm just going to leave it like that. I don't even need to stress too much about it. That is now the height, right? B in this formula is the height of my right triangle. So now I can take my equation and I can say, okay, volume is equal to big B times h divided by 3. I know big B is 20. I know that the height is the square root of 45. Divide that by 3. and I can now punch that into my calculator to get an answer. And I, in this case, got 44.72. And again, our units is going to be feet cubed because I'm talking about volume. So 44.72 feet cubed. All right, so let me show you real quick my work on that. Let me zoom that out a little bit. Too close. There we go. So this would be the picture that I drew for that. So you could take a look at that. Pause it if you need to so you can copy down what you need from it, but that is how we found that. Example 2 is find the volume of a pentagonal pyramid given a slant height of and a side length of 12 centimeters and a surface area of 2,000 centimeters squared, and then the height is 10 centimeters. I had to add that at the end because I realized I didn't give enough information. So again, let's pull up a picture. This is a pentagonal pyramid. So it means we're going to have a pentagon on the bottom that goes all the way up top and makes a single point. Boop. Incoming. There it is. Okay. So you would draw this picture the best you could. Zoom that out just a little. Okay. Draw this as best we could, and ultimately it said it has side lengths of 12 centimeters. So I know that these sides are going to be 12 centimeters long all around. Okay, and it said that it had a slant height of 12 centimeters as well. So I know that if I came straight down one side of this pyramid, that would also be 12. I know that doesn't look like it based off the picture, but we're going to pretend. And I know the actual height from top down to the very center. The actual height of the pyramid is 10 centimeters. Well, I got to think about this because they gave me the surface area. If I just try to plug into the formula, the problem is I don't know the area of the base, right? I could figure it out. I can tell you can figure it out. It's a lot of work, though. But we can use the surface area to do that pretty easy, right? Surface area of a pyramid is going to be equal to base plus the perimeter times the slant height divided by 2. Well, let's plug those things in. I know the surface area is 2,000. I don't know what the area of the base is, but that would help me if I knew it, find the area. I can find the perimeter, right? The perimeter of the base is easy. There's 12 5 times. So I'm going to have a perimeter of 60. My slant height is 12 divided by 2. Well, I can work through that, right? 2,000 is going to equal B plus 60 divided by 2 is 30. 30 times 12 is 360. Subtract that 360 from both sides. I end up with 1840. What? 1640 equals B. So I now know that the area of my base is 1,640. So now I can find the volume really easy, right? Volume is big B times H divided by 3. Big B, we now know, is 1640. We know the height was 10 and divided by 3. So we'd plug this in then. 1640 times 10 would give me 16,400. And 16,400 divided by 3 is going to give us 5,466.67. And again, we're going to put our units. This was in centimeters, so we'll put centimeters cubed. And that would be how you take a surface area and come backwards with it. So showing you my example again. There it is. So go ahead and pause that, take a look. The next volume is going to be volume of cones. Should be very similar, so you'll be okay with that when we get there. Best of luck. Let me know if you need anything answered or any questions. I will be in office hours. Come see me. Bye.